Stevenson. So the question is, what does Minority Report, Black Mirror, and 1984 all have in common?
They're all really cool.
So, it's not the fact that they're all forms of media, nor is it the fact that they're all part of dystopian futures. Instead, it's the fact that they each talk about predicting crime in one form or another. Whether it's the precogs in Minority Report, the recaller in Black Mirror, or the thought police in 1984, each of these forms of media look at how we could predict crime, but more specifically, the repercussions of doing so. And that's what we're going to be talking about today. We're going to be talking about how we can use natural language processing, a form of machine learning, to help us predict crime. So, for those of you that know me, will know I'm not a mathematician, and I'm also not a police officer. So why are we talking about natural language processing, which is quite mathy, and predictive policing, which, as the name may suggest, is all about law and crime? And well, it comes down to this quote. The idea that intrusion analysis, security analysis, is about far more than the tools we use. It's about innovating, and it's about looking at new ways that we can protect ourselves against attacks, but also predict those attacks in the first place. So what am I actually going to be talking about today? Well, I want to break it down into 3 areas. I want to talk about what predictive policing actually is. I want to talk about what natural language processing is. And then finally, I want to talk about how we can merge these 2 ideas together. How we can use natural language processing to predict crime. Before I begin, though, who am I? Well, my name is James Stevenson, and this time 2 years ago now, I was a student at the University of South Wales, studying computer security. Before that, I was an intern at Deloitte Logic, a cloud security company, and these days I'm a software engineer and security researcher. But jumping straight into it, what is predictive policing? I keep talking about it, but what actually is it? Because if we're going to use natural language processing to predict crime, then we kind of need to know what predictive policing is in the first place. And predictive policing comes down to 2 main areas: location-based predictive policing and individual-based predictive policing. Now, as the name may suggest, location-based predictive policing is all about looking at an area. It's about saying, in this area, in the future, is a crime likely to occur? Now, this is a map of London between a specific time period, where the colours show where and when crime has occurred. And it's data like this that's really useful for location-based predictive policing, because we can use this data, or we can say, okay, if a crime has occurred under these specific circumstances in the past, then it means that a crime is likely to occur under these same circumstances again in the future. Now, today we're going to be focusing on individual-based predictive policing, the idea of looking at an individual and saying, how likely is this specific individual to commit a crime? And when it comes to individual-based predictive policing, there's a whole array of approaches, theories, and methodologies that we can use to help us predict crime. And today we're going to be focusing on 3 of these. The first theory that we're going to be looking at is called strain theory. Now, strain theory is the idea that society puts pressure on individuals to achieve specific goals, like the American dream. But when individuals lack the means to achieve those goals, they're more likely to commit crime so that they can achieve them. The next theory that we're going to be looking at is called social control theory. Now, what this theory states is it states that individuals who lack close relationships, commitments, values, or norms, again, are more likely to commit crime because they don't have those relationships or values as an anchor in society. And then finally, we're going to be looking at social disorganization theory. Now, what this theory states is it states that location is key. If an individual lives or works in an area known for a specific type of crime, this theory states that intrinsically, by just being there, we're more likely to commit crime. So far, we've looked at what predictive policing is, different types of predictive policing, and how we can use predictive policing approaches to predict crime. But this talk is all about natural language processing. It's all about how we can use natural language processing to do just that. Before we dive into natural language processing, however, we need to understand what language is in the first place. And for us, as human beings, language comes down to 3 main areas: speaking, reading, and writing. Things that we all do every day. So because we do these things every day, most of us, or maybe some of us, will be able to answer this next question. And that's the question of Paris minus France plus England equals what? Now, the answer is London, because Paris is to France, as London is to England. Now, if we knew that was the answer, great. But why did we know that was the answer? Well, we would have known that that was the answer because of the experiences we've had. We've read books, gone on the internet, spoken to people. And this is all built on our knowledge base and our understanding of the world. And so, if we were to feed that question into our natural language processing machine, would it be able to answer it? Well, yes, but only if we gave it the right context. So this is the Wikipedia article for London. And if we fed this into our natural language processing machine, it would learn from the surrounding context. It would learn that London is a city, that London is in the UK, of which England is as well. Again, building on that understanding and building on that context. And so, if that's how natural language processing works, how does sentiment analysis work? Because sentiment analysis is a form of natural language processing that allows us to look at a specific piece of text and to say, what is the emotion? What is the sentiment behind that text? And again, when it comes to us as human beings, we have 8 main pillars to our emotions. But for sentiment analysis, we only really care about 2. That's positive emotions and negative emotions. So how do we translate those 8 down to 2? Well, when we're talking about positive emotions, we're talking about this top row, trust, joy, anger, and surprise, with anger being the red herring. And when we're talking about negative emotions, we're talking about this bottom row. And so, if these are the emotions that we're talking about when we refer to sentiment analysis, how do we actually get that emotion from text? Well, it's the same as most machine learning approaches. We take a massive data set. So for us, that's going to be restaurant reviews. We're going to break each of those reviews down into 2 main elements, the actual review and then the sentiment of that review. For example, I love my local pizza restaurant, positive sentiment, or this place has really gone downhill, negative sentiment. We then break that data set down into 2. We have our training set and our testing set. And when it comes to training our natural language processing machine, we look at the keywords. We say what keywords are more prominent with a positive sentiment and what keywords are more prominent with a negative sentiment. Then when it comes to testing, we look at the remaining entities. And we ask our natural language processing machine to tell us what it thinks the sentiment is. Then if that matches the sentiment we know them to have, great. If it doesn't, it means that something has gone wrong. And so if that's how natural language processing works, if that's how sentiment analysis works, then what already exists? What are some examples of natural language processing in the real world? Well, this is AWS Comprehend, or specifically Comprehend Medical, which is Amazon's approach to natural language processing when it comes to healthcare and medicine. A doctor or healthcare professional will type in a patient's details, symptoms, information. The natural language processing tool will go off, do its thing, and it will come back with key bits of information it thinks that healthcare professional needs to know. Next we have Tay.ai. Now, Tay.ai was Microsoft's approach to natural language processing when it came to a Twitter chatbot. Tay would tailor its response to people, depending on how people spoke to it. Now, it was quite controversial. It lasted just under 24 hours, but nonetheless, is a great example. And then finally, we have predictive text. So whether or not you have an Android or an iPhone, the way that predictive text most probably works on your device is by using natural language processing. So there we have 3 great natural language processing examples with healthcare, communications, and mobile phones. But none of those examples look at how we could use natural language processing to predict crime, which is what this talk is all about. So this is Alice, and it's Alice's job to do just that. It's Alice's job to predict crime. The way that Alice currently does this is she individually and manually goes to different websites, different chat forums, different social media accounts, and she profiles specific individuals on their likelihood of committing crime. The problem with this is that it's slow and laborious. So how could we take this to the next level? Well, we could automate it. We could scrape these websites for information relating to specific individuals, apply our natural language processing and predictive policing techniques, and then return to Alice a risk, a score, a likelihood of how likely these specific individuals are of committing a crime. And then, of course, Alice and her team can action those individuals accordingly. So if we were to build a framework like this, what would it look like? Well, first of all, Alice and her team would need to sit down and decide on an impact for each of these individuals. If this individual was to commit this crime, or was to perform this attack, what would the impact be? And this comes down to those three main areas: the loss of confidentiality, integrity, and availability. Once we have an impact, we can work out our likelihood. What is the likelihood of this individual committing this crime or performing this attack? And this is where we look back to those predictive policing approaches that we mentioned earlier on. We scrape these websites for text relating to a specific individual. We apply our natural language processing techniques. And then first of all, we say, does this text contain reference to any goals or aspirations? And if so, what is the sentiment? Next, we take that same bit of text, but now we say, does this text contain reference to any close relationships? Any individuals, any groups, any organizations? And if so, what is the sentiment? Finally, we take that same bit of text, but now we say, does this text contain reference to the individual's location? If so, is it a location known for this type of crime? And finally, what is the sentiment? We then go through each of these layers, aggregating a score as we go. And this score defines the overall likelihood of this specific individual committing a crime. Now that we have our impact and our likelihood, we can work out our risk. What is the overall risk of this specific individual committing a crime? Penultimately, we can use natural language processing to pull additional information from this text. Information like common topics or trends, age, gender or race, salary, occupation, religion, and any dates and times. Now, the reason why we haven't focused on this information today is because this information has the scope of becoming significantly more biased. And that's really a talk for another day, but we will touch on it later on. And then finally, we just want a naming convention. A naming convention that we can use to instantly identify these individuals without including any of that personally identifiable information. So here we could use a hash, we could use an IP address, we could use a random word. This is just one example. This is broken down into 4 areas: the source of the data or time it occurred, the risk level, which is what we worked out earlier on, and then a pseudo-random word to give the name some uniqueness. And there we have it. We've looked at what predictive policing is, what natural language processing is, and how we can merge these two ideas together. What I'm going to do next is I'm going to go through some questions that I normally get as part of this talk. I'm going to wrap the talk up, and if we have any additional questions, we can go through them now. So the first question we have is predictive policing better than normal policing? And the answer is no, right? Predictive policing is a tool, it's a supplement. It's something that should be used in addition to normal policing, and isn't here to replace police, nor is it here to replace police intuition. Second question we have is predictive policing biased? And the answer here is yes. Predictive policing is quite biased. The problem we have with predictive policing is that it's garbage in, garbage out. If our data is biased, it means that our frameworks are biased also. And the problem we have with crime data is that it's intrinsically biased. Because we have so many undocumented or less documented crimes, like assault, it means that the data we have isn't representative of the real world. The second problem we have when it comes to machine learning and bias is that these tools, these techniques, these frameworks are created by human beings, who again are intrinsically biased. The next question we have is predictive policing used in the real world? Yes, so there's an example of it being used in the States. There's a scheme run by the LAPD, it's called LASER. The way that LASER works is it assigns a score to ex-offenders on their likelihood of repeat crime, and if those individuals fall into a top bracket, they receive a follow-on visit from police. Finally, we have how good is natural language processing at picking up nuances or differences in text. Now, there's an example I like giving here, which is a natural language processing tool that can simultaneously understand 2 different languages. And I find this really interesting because it goes to show that in some cases, natural language processing can be better at understanding text than some of us as human beings. So at this stage of the talk, you might be thinking, oh, James, this is really interesting. Or you might be thinking, oh, James, you're a terrible human being. Either or, you might also be thinking, why are we talking about predictive policing at a computer security conference? And again, it comes back to this quote. The idea that intrusion analysis, security analysis, it's about far more than the tools we use. It's about innovating, but it's also about thinking outside the box and looking at new ways that we can protect ourselves against attacks, but also protect ourselves from those attacks in the first place. Now, for me, I care less about natural language processing. I care less about predictive policing. I care more about how we can apply these areas to computer security. In fact, starting this September, I'm starting a PhD in the UK with that question. The question of, can we predict malicious actors? However, for now, that is this talk coming to a close. If you have any questions, feel free to ask me now. Come find me afterwards. I'm also on Twitter, _ James Stevenson. And if you're interested in any of the research that's gone into this talk today, you can find it on GitHub under Hunch. Once again, thanks all for coming along, and thank you for the organisers for having me. Thanks, everyone.